Hi, my name is Ian, and we're going to do matric finance. First of all, I'm going to run through a couple of the principles with finance, a couple of formulas, a couple of numbers that we've got to have a look at. I'm going to show you where to find the formulas on the formula sheet so that you get them right, and then I'm going to work through a couple of questions. So, where did we start off with finance many years ago back in grade 8? Well, we started with simple interest. And our formula, the amount we get out, is the principal 1 plus IN. Now that was fantastic, really easy. We got the same amount back every time. Also, when we came to depreciation, we had a thing called straight line depreciation. And if we have a look at that formula, it's exactly the same, but we just have a minus. So that's our straight line depreciation. Then we came on to the wonder of compound interest. And suddenly our money was growing exponentially. Got to remember that I is the interest rate per period, and N is the number of compounding periods. I'll come back to that in a second. Unfortunately, if we buy a car, for example, it depreciates over time. So we came up with reducing balance. Now, reducing balance depreciation meant that over a long period of time, our asset, car, whatever it was, always had a value, even though it was really, really small. That's why it's reducing balance and not straight line. But the formula almost exactly the same as the compound interest, but it's got a minus on it. Now, on our formula sheet, those formulas are found in the second line. The first two, the simple, the one of the minus reducing straight line depreciation, compound interest, and reducing balance depreciation. There they are. Now, what I said a few moments ago was I said that the I in our formula was the interest rate per compounding period. So, you just got to remember, if it's annually, it's going to be once a year, and if it's for 4 years, it's going to be 4 times 1 times 4. If it is semi-annually, or perhaps biannually, it's going to happen twice a year. So, if you were quoted, and here's a little example, at 10% per annum, semi-annually or biannually, your compounding period would be 10% over 2, or 5% every 6 months. Also, if it was for 4 years, our N would now increase, because it's not happening once a year, it's happening twice a year. So we would have the 4 years, our example we're choosing, times 2. And that carries on for monthly, 12 times a year, for quarterly, 4 times a year, and in real life it happens daily, where they take the interest rate and they divide it by 365,25, and that's going to happen 365,25 times a year. Now, as a matter of interest, just so that we know that these questions I'm going to work with actually are related to real life, and you could take the numbers that I'm giving you now and just work out certain things, is we have the Reserve Bank. And at the moment, their interest rate, the benchmark interest rate, is sitting at 5%. What does that mean? They will lend money to the commercial banks, FNB, ABSA, Capitec, Volkskas, etc., at 5%. Then they will lend money to you at a slightly higher rate. If you deposit money, you need to negotiate the best rate that you can. But this is just a benchmark. The Reserve Bank benchmark is 5%. Over the last year, 5.5%. And how about this? In 1998, think about history, think about where the nation was. It was at 24%. Now that's what the Reserve Bank are lending money at. 24%. Wow. To try and have the repayments on a house then, almost impossible. At the moment, our housing rate, our bond rate, is sitting at 8.5% per annum, compounded monthly. So, you have a house, 800,000. You will be paying about 8.5% per annum, compounded monthly. And obviously, with future value and present value is as part of the syllabus, these are scenarios which we're going to be working through. I mentioned future value and present value. Future value formula and present value formula appear over there. Future value and present value. So, top line was simple and compound interest, and our two depreciations, there are future value and present value. Now, future value, what does that actually mean? I say future value is fantastic because you've got savings. You're putting money away every month to have money in the future. That's why it's future value. Our present value formula, so let's just make a note here. Future value savings. Present value formula means you have lent money. You've gone and got a bond. You've gone and got some money to pay university fees or something like that. All right, that's our intro. We're going to tackle a couple of questions. Question number 1. How many years will it take for an article to depreciate? Right, there we go. Depreciate according to the reducing balance method at 7.5% per annum. Well, fantastic. Pop on our formula sheet and we know that A is equal to P into 1 minus depreciation. It's getting less. The value is decreasing, unfortunately. I to the power n. All right. Part 2, we have to realize that they don't actually give us a value. They don't say, you have a Porsche Boxster at 1.5 million and in 10 years' time it's going to be how much? They're not giving us a value. Half the value. 2 ways to do this. I could say, well, it now is 100 and it was 200, and then we're going to put the other numbers in. That's one way to do it. Or you could say, it is 200 now, it was 400. You can select values. You could, however, say X and it was 2X and continue the formula like that. Your choice. In any rate, I'm going to stick with a 1 and a 2. Small numbers, I'm happier. 1 minus, and it was quoted at 7%, and we need to find the value n. How many years? Another thing I do is, because of the calculator, and I'm going to pull it up now, we can see that the calculator has a percentage button on it. There, the Casio calculator nowadays has a percentage button. I'm going to use that percentage button. Some people say that you have to say 0.07. I just think if we've got a percentage button, let's use it. All right, here we got our little problem. Let's go back and see how we're going to solve this. I'm going to divide both sides by 2. Let's extend our page. I'm going to divide both sides by 2. And so here I'll have 0.5. And that's equal to 1 minus 7.5, 7% all to the power n. How am I going to find n? Now, I got 3 different ways of doing it. One, I'm going to use logs. One, I'm going to use trial and error. And one, I'm going to show you table method on the Casio calculator. We know with logs, the base stays the base and the other two swap over. So I could write this as log base 1 minus 7% of 0,5 is equal to n. Let's pop up our calculator and do that. I call this the log big building, little building. And it really is an amazing function on the Casio calculator. So we'll have 1 minus 7. And we're going to say of 0,5. And we hit our button and we get that n is equal to 9,55 years. Fantastic. Over and dusted. Now, if I have a look at an alternate method of doing this, I have 0,5 and I'm going to put that in my calculator to work out what it is. So clearing that, 1 minus 7%, shift and percentage, that gives me 93 over 100. And that is going to be to the power n. What I'm going to do is I'm going to run a trial and error. I'm looking for an answer of 0,5. So here we go. Clear our calculator. With our fraction button, we're going to have 93 over 100. And we're going to raise that to a whole bunch of numbers. I'm going to try the number 6 for starters. No, not 0,5. Not there yet. So, let's try another number. Let's try 7. Oh, 0,60. It's getting closer to 0,5. Let's be a devil and go to 9. Ah, 0,52. Oh, getting really, really close. Let's try 9,5. Ha! Getting even closer. Now, you might think that this is laborious. All right? You don't know how to do logs? How else are you going to do it? This is trial and error. Remember, on your exam script, write trial and error and show one or two of the numbers that you've put into the calculator and the answers you've got. And you'll hone in, you'll get closer and closer and closer to the answer. Now, running a table function, we will need to go to setup 3 as our table, and once again we're going to put our fraction button and have 93 over, oh dear, let's just go back, delete that, there we go, over 100, and we're going to raise that thing to the power x. We're now going to let the calculator work out a whole bunch of those trial and error answers. So here we got 93 over 100 to the power x. Let's start at 0. Why not? Let's end, okay, let's just say 10. This is an adaptation of trial and error. And now we pop step of 1 and out pop the answers. So all I need to do is I need to scroll down and have a look at how the numbers in the right-hand column are changing, and I will notice that between 9 gives me 0,52 and 10, 0,48, I have my answer of 0,5 that I'm looking for. So what can I do now? It's between 9 and 10. So I'm going to use the same function, and I'm going to start at 9, and I'm going to end at 10, and I'm going to use steps of 0,5. Oh, that's a little bit small. 5. And there we can see that it gets closer. What you can do is to make those steps slightly closer every time. All right, so logs, trial and error, or table function as a version of trial and error. Right, we've got that answer. Let's move on. Here we have a question of two friends receiving an amount of 6,000 Rand. So that'll be our A. They're investing it for 5 years. That'll be our N, unless we have to change it because it's compounded monthly or biannually or whatever. Right, so Radesh chooses the first option, 8.5% per annum, simple interest. Oh dear, simple interest. At the end of the 5 years, he receives a bonus, an additional payment. Nothing to do with the calculation. We're going to have to bung on an extra 5% of exactly 5% of the principal amount. Okay. Tundi, 8% per annum, compounded quarterly. Who will have the biggest investment after 5 years? Justify with appropriate calculations. So, here we go. Radesh. He has now taken his 6,000 Rand and he has invested it at 8.5% compound simple interest, and he's going to get an additional 5% of his 6,000 Rand. Well, there we go. I pop this into the calculator, clear, go back to mode computation, and I have my 6,000 Rand, open brackets, 1 plus 8.5% times 5, because we're in for 5 years, and he will get for the investment 8,550 plus 5% of 6,000 Rand, and I'm sure you can do that in your head, which is 300 Rand. That was his bonus, so total of 8,850 Rand and 0 cents. Right, there's Radesh. Simple interest and a bonus. Going on to Tundi. Okay, Tundi took her 6,000 Rand and she was able to invest it at 8%. Now, straight off the top of your heads, you might have said 8.5% is better than 8%. 8.5% simple interest, 8% compound interest. Initially, the 8.5 would produce more funds. But I'm telling you now, this compound interest awakening giant makes your investments grow amazingly. I just need to refer back to the question. It said quarterly. That means it's happening 4 times a year. So she's not getting 8% 4 times a year. She's getting 8% divided by 4 for every compounding period. 2%, if you want to write 2%, that's fine. I'll write 8% over 4. And it's also going away for 5 years. 4 times a year for 5 years, 4 5s, 20. That's the calculation we're going to pop in to our calculator. Up comes the calculator. Okay, so we got our 6,000 Rand, our principal, the amount we started with. And thank you, Casio, for a fraction button. You're amazing. And it's going to be to the power 4 times 5. And if you can't do 4 times 5, you can actually put 4 times 5 into the calculator. It'll do it for you. And out pops the answer. Right, let's write that down. It'll be 8,915 Rand and 68 cents. Let's slip up and compare. Well, there we had Radesh. There we have Tundi. Tundi will have more money. Well done, Tundi. Now, perhaps 5 years was quite a small period of time in investment terms. And you'll notice that there isn't much of a difference between the two. If this was for 20 years, I'm telling you, Tundi has got it made. Okay, happy with that question? Let's move on. Right, here we have Nikki, who opens an account with a single deposit. And then she makes 18 monthly deposits. So What's happening in this question is we've got two bits. We've got an initial deposit that is going to grow for our 18 months, and we've got our annuity. We're sticking in something every month that is also going to grow. Our annuity is going to grow with our future value formula. We're putting away savings. Our single deposit, one amount, bang, it's going to go with compound interest. Let's have a look. She's making 18 monthly deposits of 700 Rand each. She's earning 15%. Okay, let's write this up. Well, we're going to have the initial deposit, and that is going to be added to the annuity. So the initial deposit was 1,000 Rand, and that was 15% per annum. Divide by 12 because it's compounded monthly, and it's for 18 months. Now, this is where you've got to be wide awake. It's going in for 18 months, not 18 years. Monthly is our compounding period. We okay with that? Our annuity, that's future value formula. We're saving for the future. She was putting away 700 per month. And our little formula is 1 plus our 15% over 12. And that's going away 18 deposits. And it's all over I, which is our 15% over 12. And we pull the curtain shut on that. That's what it is. So I'm now going to pop each bit into the calculator separately and work them out. So here we go. We've got our 1,000 Rand, which is our initial deposit. We're putting that in, and we have 15%, and we divide by 12 because it's happening monthly, and it's in for 18 months. So Nikki's quite lucky. She's going to pop out with that is 1,250 Rand and 58 cents. If we pop the next bit in, once again, she's putting away 700 Rand every month. Now, that's a beautifully large fraction. On the top line, we've got our 1 plus, and here we can go our 15%, and we've got to divide by 12 because it's monthly, and there are 18 deposits, and the formula says subtract 1, and at the bottom we're going to pop in another fraction. Isn't this calculator amazing? And once again divide by 12, and we pop out at the end of the day, close the bracket, and boop, 14,032 Rand. So here we go. She has 14,032 Rand and 33 cents. Great. How much has she got at the end of the day? Add those two figures together. She'll have 15,282 Rand and 91 cents. Beautiful. Let's just go back. It was a single deposit. That's why we had an initial deposit. And then it was our 18 monthly deposits of 700 Rand each, which turned that into an annuity. Great. That's the end of the question. We're going to take a short break, and we'll see you again shortly. Well, welcome back. Hope you stretched your legs, had something to drink. Let's get stuck into it. Here we have a question. A certain amount was invested into a fund paying I% interest. Right. I bet you we're going to have to find I. And the big thing we've got to realize, compounded monthly. They tell us after 18 months, the fund at a value of what that is, calculate I. Great. So our formula, the amount we land up with is our principal, the amount we start off with. 1 plus I to the power n. Okay, so we land up with, at the end of the time, 1711,41. We started off with 1430,77. We had 1 plus I, which we're trying to find. It's compounded monthly. You've got to divide by 12, and it's on 18 months. We don't have to do a little calculation there. They tell us 18 months. 18 compounding periods. So, how are we going to use our calculator to work this all out? Well, first of all, we got our 1711,41. We're going to divide by our 1430,77. Now, how are we going to get rid of that 18? I say get rid of in inverted commas. Yes, you guessed it. We're going to have to take the 18th root of that huge fraction. And that's going to give us 1 plus I over 12. Let's pop this into our calculator, work it out. Over here, over there, that's our nth root. We can have any root we like over there. So, in we go 18, and thank goodness for our fraction button, 1711,41. That's going to be over 1430,77, and we're going to get that answer. Now, if we go back to our calculation, we can see we're going to have to subtract 1 from that, and we're going to have to multiply it by 12. And up pops 0,119999, etc. So, back to here, we have that I is equal to 0,1199, etc. And writing that as a percentage, we have 12%. There we go. That was quite straightforward. What we're going on to now is a scenario of a house. You buy a house, you owe money. You pay a bit off every month. After how many years or how many months, how much do you still owe on that house? This is the scenario that the next question is based on. Right, a father decides to buy a house for his family. 800,000 Rand, that is what he's taking out. He's taking out a bond. He's getting the money right now. We're going to be using present values at some stage. Monthly installments, which is traditional, of 10,000 Rand. Well, I'm glad he can afford that. Fantastic. The interest rate is 14%. Current interest rate, 8.5%. So, this guy's really paying. What is nice about this question is they're telling us the answer, and we've got to show that. Now, the way I've chosen to do this question is I've had to look at the balance outstanding after 233 months. How much is outstanding? And let's have a look at what happens. Okay, so if we have our balance outstanding, whoops, my spelling has gone for a second there. Our balance outstanding, how do we work that out? Well, that's our loan plus the interest that it accrues minus our repayments and the interest that gained. Okay, so what is the loan? The loan was 800,000. How are we going to work out the interest? Well, 1 plus 14%, or if you really want to, 0,14. It's monthly, and we are working on 233 months. I'm going to go 1 month less. Let's have a look at what we owe. If it's less than 10,000, then it would have been paid off in 234 months. So that is how much the loan plus its interest is. If you paid back nothing, you would be owing a huge amount. Defaulting on a loan is a very, very scary prospect. So I'm going to, over here, for want of space, work out how much his monthly investment is going to add up to. So we've got our 1 plus our 14% over 12, and that's all to the power 233, because there are 233 investments that we're going to calculate, over I, which is our 14% over 12. Now, we pop that into our calculator. So, here we go. We got our 800,000, and that is 1 plus fraction button, our 14% monthly, and that is going to be the power 233. Wow. If we didn't have any repayments over our 233 months, we would be owing 11 million rand. All right. From that, we're going to subtract. And I'm just going to keep the answer there. I'm not going to write anything down. I'm going to keep the answer there. Subtract our 10,000. And we pop our fraction button, and there's an error there. Let's get rid of this fraction. Right. He's paying our 10,000. Okay, into here we go. 1 plus our 14%, and that's happening every month, and that's going to be to the power 233, and I'm going to subtract 1 at the top there, and at the bottom I'm going to have another fraction sign, and we've got our 14%, our I, it's happening at that every month. Right, there we go. What have we got out? 4,660. So that is equal to 4,660 rand and 4 cents. Let's think about that. Here the dad has paid back 10,000 every month, and he's now on 233 months, and he's ready at the end of the 234th month to pay another 10 grand. But how much does he owe? He only owes the balance outstanding, which is 4,660 rand and some odd cents. He's going to have repaid his loan and have a little bit of change over. What a pleasure, owning your own house. I've done it one way. I love doing balance outstanding. There are other ways. You could have a look at the memo and have a look at, I think, 2 other ways. Let's move on. Right, similar scenario, well, exactly the same, but here we're coming on to 2.2.2. Suppose the father encountered unexpected expenses. Unfortunate, but sometimes it happens, and was unable to pay any installments, 120, 121, 122, and 123, 4 installments outstanding. All right, but we've already realized this gentleman is really responsible. So at the end of the 124th month, he now is increasing his payment so that he still pays off his loan after 234 months. Isn't that amazing? He is really, really dedicated to making sure his family has a home. All right. But obviously, having missed 4 payments, the expense of the house, the outstanding balance is going to grow because there's nothing to offset that growth. So we now have to work out the new installment. So we're going to have to work out how much he now owes after the 4 months of no repayments, and then work out a new financial plan. So here we go. Just popping this on a timeline so we can see exactly what's happening. Here he was paying and paying and paying and paying. On T118th he was fine. He paid his 10,000 rand, 10K. On the 119th month, he paid his 10K, no problem. On the 120th month, problem, nothing happened. So for those 4 months, nothing happened. So what we need to do is we need to work out how much was outstanding at the end of that period of time, increase it for 4 months, work out how much is going to be outstanding, a balance, and then take that through all the way to 240 months. So, timeline, just to put it in perspective. Right, balance outstanding after 119 months, because that's when things went pear-shaped. So, after 119 months, we've got our 800,000, and it's 1 plus 14% over 12, all to the power 119, and we're going to subtract the repayments that this responsible gentleman had, and that's 1 plus 14% over 12, and that's going to be for 119 months, minus 1 over our 14% over 12. Okay, we can pop that into our calculator, and I did this question a little while ago, so I know what the answer is. We're going to get out 629,938 Rand and 11 cents. So, what does this actually mean? He loaned 800,000. After 119 months of repaying 10,000 Rand, he still owes the bank 629,000. Might sound a bit depressing, but he's got a plan. So, we need to take this, and this needs to grow. Why does this grow? Because there have been no repayments. And how many months has it grown for? It's grown for 4 months. Okay, so compound interest, here we go, 938,11. That is growing 1 plus and our 14% monthly, and it's growing for 4 months, 4 compounding periods. And what's going to happen? He now owes 659,853 Rand and 68 cents. So this is the new amount that he has to pay off. So here we go. He presently owes this money, so let's try and work out a plan for him. We're going to be using present value formula. Okay, so we know that this is going to be equal to the new repayment plan, whatever that's going to be, 1 minus 1 plus our 14% over 12 to the power minus 111. Now, where do we get 119 from? Where do I get 111 from, I mean? Well, we went 124 was over here, and here he went, 125. So from 125 all the way through to there, how many repayments is he still going to make? Yep, you got it right, 111. And finishing this off, we get that. So, how am I going to work this out? This over here is going to be equal to that over there. Well, quite easy. I can take this value over here and I can divide it by the bit that's on the end, this bit over here, which I've put pink brackets around. And then we will get our x. We can pop up our calculator and we can do the whole calculation. But because I want to save a bit of time, I've done it before, and I get x is equal to 10,632 Rand and 39 cents. That is what our new payment plan is going to have to be. We're going to take a short break, and we'll see you again shortly. Welcome back. Hope you stretch your legs. Last question for now. Sinking funds. What is a sinking fund? If I've got an item and it's going to depreciate in value and eventually I'm going to have to sell it, if I sell it, my business goes bang. So I'm going to have to replace it. A sinking fund is a savings fund so that when I get rid of my old printing press or whatever I've got money to acquire a new one. Let's have a look at the question. Right. Mark Small Business, Postal Emporium, has a photostat machine, 200,000 Rand. The photocopier depreciates on a reducing balance at 20%. He wants to buy a new machine in 5 years' time. Great. There we go. 200,000, it's going to drop at 20%, reducing balance, 5 years. He wants a new machine. My goodness, look at this. Isn't this phenomenal? It's escalating at 16%. Wow, that's outstripping inflation. I hope it's a really, really good model. The old machine will be sold for scrap value after 5 years. Sinking fund is going to be set up. That's the sinking fund. And we're going to be paying equal monthly amounts into the sinking fund. And we're going to earn 18% per annum compounded monthly. Okay, let's have a look at the questions. Find the scrap value of the old machine. Well, it cost 200,000 when it was new. and it is depreciating, the negative, at 20%, and it's over 5 years. Pop that in our calculator, and it's now worth 65,536 rands. That's it. That's the scrap value. Isn't that phenomenal? 5 years, a 200,000 rand photostat machine that can sing and dance drops in that value. Right, moving on. 3.2. Find the cost of the new machine in 5 years' time. Now, remember that I commented that the increase was quite outstanding, quite staggering actually, 16%. So our new machine in 5 years' time is going to appreciate and cost us 420,068 rand and 33 cents. That's how much the new machine is going to cost us. Guys, that's 16% increase. Wow, that's heavy. Okay, so he had the machine, it's got a scrap value. To buy the new machine is going to cost him 420,000. Let's have a look over here. The next question says, find the amount required in the sinking fund. Remember, we're going to sell it for scrap. That's how much we're going to need, and then the difference between the two is going to have to be in our savings fund or our sinking fund. So we'll take the cost of the new minus the cost of the scrap and pop those two values in our calculator, and we have a sinking fund of 354,432 rand and 33 cents necessary so we can buy a new machine and continue with our business. Wow, quite daunting. Find the equal monthly payments made into the sinking fund. We need this money in the future. We're going to look for the future value. So, what were our numbers? Well, we needed 354,432,33, and we're going to be putting away X rands every month using our future value formula, 1 plus, and isn't this amazing? There it is. We can earn 18% compounded monthly. That's quite phenomenal in this day and age. But this is just an exam question, so let's go for it. -1. Okay, so here we go. The first payment will be paid immediately, and the last payment will be paid at the end of the 5-year period. So I've written the number 61 over there. And some of you are going to wonder where that came from. So let me just run a quick timeline. Here I go, and I put away my first X. And after the first year, I put away my next one. And after my second month, putting away monthly, I put away my next X. And that continues on and on and on and on and on until the end of 60 months, which is at the beginning of the last month. So at the end of the last month, I would have actually made my 61 payments. There we go. We started immediately. At the end of 60 months, I now have 61 payments. And that is why I use the number 61 over there. All right. Putting our numbers into a calculator, we can get that X is equal to our 354,432,33 times 18% over 12, and that's over our 1 plus 18% over 12, all to the power 61 minus 1. Now, just in case you wonder where that came from, going back up, I didn't write all this down. That was silly. I'm taking this whole thing over here, and I'm dividing it. I'm dividing the 354,000 by that number. So if I'm dividing by a fraction, I'm going to tip in times, and that's why this little bit landed up on top. Okay, popping out our trusty Casio calculator, I can put that in and press the equal sign, and we will get that every month I need to put away 3,593 Rand and 55 cents. All right, if I want to assure my company that I'm going to be able to purchase a new photostat machine, I need to put away 3,593 Rand and 55 cents every single month without fail, or else I'm not going to have an income. Let's move on. Right, here's the question. Suppose the business decides to service the machine at the end of each year for the 5 years. The service is going to cost 3,000 Rand. We're going to be taking money out of our sinking fund. But not only are we going to be taking money out of our sinking fund, when we take it out, it's not going to earn interest. So our sinking fund is going to diminish. And the question says, how much is it going to diminish? What's the reduced value? Now, if we just have a look at what's happening, at the end of 12 months, we're going to be taking out 3,000 Rand. Same at the end of 24 months, we're going to be taking out 3,000 Rand. Same at 36, same at 48, and the same at 60 months or the end of 5 years. So we're going to be taking out 1, 2, 3, 4, 5 bits of 3,000 Rand to service our machine. But hang on, this one over here is going to miss out on 48 months of interest. And this one over here is going to miss out on 36 months of interest. And similarly, they're going to miss out on bits of interest. However, that one over there is not going to miss out on any interest. So let's work out our calculation. So we got 3,000, and our first bit is going to miss out on 48 months. And our second one is going to miss out on 36 months of interest. And our third one is going to miss out on 24 months of interest. And similarly, this one is going to miss out on 12 months of interest. And the last one is going to miss out on no interest. Put that into your calculator, just type the whole lot in, and bang, out is going to pop 22,133 Rand and 22 cents. Now, what does that mean? That means we've lost that money from our sinking fund. Yes, worthwhile cause, service your machine. But we're going to need to make up another 22,000 in our sinking fund. So what has actually happened is our fund has reduced. Our fund has reduced to 332,399 Rand and 11 cents. From it was 354,432 Rand and 33 cents. So there we have it. Now, the last question is going to say, if we're going to pay for our services out of our sinking fund, what are we actually going to have to put in? The scenario is there, and the question is there. Calculate the increased monthly payment into the sinking fund, which will yield the original. Okay, so our original was 354,432,33, and we need an additional 22,133 Rand and 22 cents for services, and we're going to need a sinking fund of 376,665 Rand and 55 cents. So this was our initial, and these are our services. So this here is our new total. That's how much we have to have in our sinking fund. So what are we going to do? We're going to use our formula, our future value formula, because this is the amount of money that we need in the future. And we're going to work out our new X, our new monthly repayment. Popping all the numbers in the formula, 1 plus 18% over 12 because it's monthly, and it's going to be in for 61. Remember, we discussed the 61 a while ago. And what I'm going to do is I'm going to take this value over here and divide it by that value over there, just using the incredible power of our calculator. And X is going to come on to 3,817 Rand and 90 cents. By comparison, we were paying 3,593.55. So in effect, there's not a lot of difference, couple of hundred Rand. But our photostat machine is serviced every year, and it's going to be in tip-top shape. All right, guys, that's it for today. Good luck.